Welcome back, my dear students, to my channel Civil Knowledge. So, in this session, we will continue our chapter, that is Introduction to Civil Engineering, session 2. Okay, first we will see the table of contents and we will continue our chapter. So, we have already seen some of the topics under the table of contents. Okay, so the remaining part I will continue in this session. So, remote sensing and GIS. So, what is this remote sensing and GIS? Remote sensing is defined as the science and technology by which the characteristics of object of interest can be identified, measured, or analyzed. The characteristic without direct contact. See, in this technique, without touching or without going there physically, we can interpret a object. Okay, so that technique is called as remote sensing. See here, remote sensing is defined as the science and technology by which the characteristics of object of interest can be identified, measured, and also it can be analyzed. Okay, the characteristic without direct contact, so we need not to be there physically, but we can identify its measure, or we can analyze the any object which we need to investigate. Fine. So here in this technique, see here, so it is done by satellite. Okay, so in the satellite, sensor will be there. So here you can see one building. So in the building, some object is wanted by the picture. Some object needs to be viewed. So what he does, in the reflection of sunlight, what he does, he directly directs the sensor towards the object. Okay, here due to sunlight and its reflection, so it is captured by the sensor. Okay, once it is captured, then it is sent to the person who is sitting here. And what he can do, so directly he gets the image. Once he get the image, he can interpret it, he can analyze it, and information, maps, and statistics for application can be collected. So without moving, so this person wanted the knowledge or information from this person, he got without any physical contact, or it didn't go there, just it was done by fraction of seconds by the technique called remote sensing. Next is GIS. So GIS is all, you are all aware of the Google Maps, right? So wherever you want to go, you can just check your mobile for Google Maps. In the Google Maps, you can see these views. Okay, once you open your Google Maps, and you can see this type of pictorial forms. They are all done by the technique of geographical information system. So this geographical information system is a framework for gathering, to collect, managing, and analyzing data rooted in the science of geography. The GIS integrates many types of data. It analyzes spatial location and organizes layer of information into visualization under maps and 3D series. Okay, it will collect the data, it will manage it. Okay, it will analyze it, and it will show in the form of maps and 3D data. So you can see here, so good mapping technique helps us to get required information accurately, okay, and effectively manage and monitor the available resources for optimal use. See the Google map layers. If we in the Google Maps, if we select the satellite view, we are getting this. Okay, if you want only the road and transport, you are getting this view. Okay, try it in your mobile, so that the layer of working of GIS system, the beauty of GIS system, you will get to know about it. So GIS is an high-tech equivalent of map. It represents means to locate ourselves in relation to the world around us. It deals with the measurement, mapping, monitoring, and modeling of geographical information around us. So this was about remote sensing and GIS. So it is also a branch of civil engineering. So next is your structural engineering. So the structural engineering is the branch in which we deal with the basic elements such as beam, slab, column, frame, shelves, etc. So here you can see the structural examples. Okay. See, structure is the assemble of two or more basic elements such as beams, slab, column, truss, frame, shelves, etc. See, here bridge is there, so it is supported by this. Okay, so it is a bridge. It is held by the ribbons. Fine. It's a cable stayed bridge. So it deals with the requirement considering design for limit state of collapse and serviceability. So okay, for structural engineering we have a code. On that code, following that code, it will lead us to the safe values so that our structure is safe. So the structural engineering allows us to design of new structures. We can upgrade existing structures. Intelligent use of new technologies and materials to control structural behavior can be studied under structural engineering. Structures include building, bridges, offshore platforms, transmission towers, and other specialized facilities. So in the picture you can see the Burj Al Arab in the UAE. It is a 7-star hotel. So it is done by a civil engineer, mainly a structural engineer. Okay. So we can see more examples of structures in the images now. So this involves determination of support reactions. In the structural engineering, mainly what we require is the deflection. So whatever the deflection we are getting, for that deflection we are calculating the moment. Okay, we are calculating the moment and we are giving support to that element. So involves determination of support reactions, member forces and moments, deflection and deformation. Okay, so in the structural engineering we find all, if any element is given, we find the support reactions. Okay, the member forces, what are the forces, the moments, and what is the deflection and what is the deformation, all will be known under the structural engineering. It also deals with the planning of position, layout of different elements and design. So determination of size, shape and material of components such that safety and serviceability required are not sacrificed yet economy is concerned. So structural engineering allows us to design any material, okay, design any element so that safety is also ensured, with that economy is also under budget. So repair, rehabilitation and maintenance is a part of the structural engineering. Dams, bridges, stadium, auditoriums, multi-story buildings are analyzed and designed in our structural engineering. It is a vast branch in the civil engineering, so that we can see complex problems in that branch. So next comes our surveying. So surveying is a science and art of determining the relative position of points on, above or beneath the surface of the earth by means of measurement of distance, direction and elevation, either directly or indirectly. So basically surveying is a science, or it is an art of determining the relative position of points. So if a point is here, okay, in the space, so this surveying allows us to determine the points where exactly it is. So this point, how it is relating to this point, okay, how this point is related to this point. So we can do, or we can take advantage of surveying to find relative position of points with respect to each other. So it is called as the art of determining the relative position of points on, above or beneath the surface of the earth by means of measurement of distance, direction, elevation, either directly or indirectly. So activity involved in collection of topographic features of a location for future construction, surveying necessary. So surveying is the objectives of surveying we'll see. So execution of survey to collect topographic data, calculation analysis of data, plotting survey data to create design maps, provision of line, grade and other layout works. So everything is done in the surveying. So to draw a map of any specified region, surveying essential so that we can pick necessary point and it is surveyed with respect to each other so that we can we can join them and we can get a map for that any purpose. Okay, so if we are doing anything, so surveying is the basic thing to measure an area so that we are getting our purposed location. So this in the picture you can see this is the total station. It is the advanced surveying instrument. Okay, so the tripods run with the total station. So once you enter the branch, you will get to know about them. Next we will come to the transportation engineering. So this transportation engineering allows or it involves the planning, design, construction and operation and maintenance of transportation facilities. So what are these transportation facilities? Roads, railways, airports, navigation, like that. So application of scientific approach, planning, design and management of transportation systems such as roads, railway, sea or river and airports. So this is done in this transportation engineering. It involves planning, design, construction, operation and maintenance of transportation facility. In airstrip, runways, roads and railways, the study includes the design of pavement system. So maintenance and upgradation of docks, harbour, airport, railway station based on requirement of population growth is a part of the discipline. So everything related to transportation, either it is a roadway, railway or it is a navigation or airport way. Okay, so everything is dealt in this transportation engineering from the part of construction to the execution. Transportation engineering is required. See in the figure you can see the cross section of a road. Okay, so this is the sewer, this is the telephonic cables. So everything is designed as per the code and every element have its specified place where it should be placed given by the code in the transportation engineering. Okay, so this is the sidewalk, this is called as curb. The carriageway is the one where the vehicles move on. Okay, so any sewer is there, so to connect that sewer a manhole is there on the surface of the road. So the road may be single lane or double lane as the road is it's a national highway or it is a state highway or it's a village road. So everything is dealt in the transportation engineering. So what is the design criteria if it is a national highway? What is the design criteria for state highway? What is the design criteria for village roads? Okay, middle district roads. So everything is given under the transportation engineering. We will study in detail about them when we come under the subject of transportation engineering. So this is the advancement, is an example of advancement of transportation engineering where the carriageway is also there and a pedestrian is walking under the carriageway also. So here you can see a 6 lane 1 2 3 4 5, so 5 lane roads. Okay, that too depends upon the traffic volume, so the lanes are being decided. Okay, so this all the things related to this is only about the road which I am showing. So you can roadways, so you can find every railways also comes under the, so how the railway rails are there, it's a broad gauge or narrow gauge, everything. In airport, how should be the airstrip, everything is dealt in this transportation engineering. Okay, now let us see the scope of transportation engineering in India. So the scope of the transportation engineering is it contributes to the economic and social cultural development of any country. Okay, urbanization and industrial attract the surplus labor from rural areas. To promote the public transport and mass transport, the transportation engineering is beneficial. So next, to optimize the transportation cost, maintenance and administrative overheads, transportation is needed. So evaluating the alternative using the best cost divided by benefit ratio. Cost benefit ratio techniques are used to find the minimum distance between the two places so that the road, the way, okay, is economical and also time saving. So provide content study for program adoption and implementation with the citizen partnership and updating the plan. Okay, so it involves accident study for safe and comfort transport system. So here the transportation engineering also studies the various cases including the accident study. So they are putting the signboards so that it should not be happened. So like this benefit measures are being taken under the transportation engineering, and it is used in our day-to-day life. So here I conclude this topic. So thank you for watching the video.